Hey everyone, welcome to Geom, section 7.5, proportions and triangles. Here's the notes video. Now rather than have the paper on that one program and then try to like hand draw stuff, I just put all the problems in a PowerPoint. So I think that's going to be a little bit easier for us. So let's take a look at the notes up there at the top. So there's something called the triangle proportionality theorem. This is also known as the side splitter theorem. Basically, if you've got a triangle and you've got a side that's parallel to another line inside the triangle, like shown here, it splits up the sides of the triangle proportionally. So what we can do is we can say this top part over this bottom part equals this top part over this bottom part. Okay? And this lesson is all about setting up proportions. So there's the first thing we just talked about. And then the next thing, the converse of the triangle proportionality theorem, I'm not too worried about that. Basically says if the sides are divided up proportionally, then the lines are parallel. But we're not going to deal with that too much. So the next thing, the two transversal proportionality theorem. Basically, it's the same thing as the side splitter theorem, except the two sides don't connect and make a triangle. It's just two sides, but everything's split up proportionally. So this top part AC over this bottom part CE is going to be equal to this top part over this bottom part. And then we'll talk about this a little bit later, the triangle angle bisector theorem. Basically, if you have an angle bisector, it splits up that third side proportionally with the other two sides. So I could say 40 over 15 equals 24 over 9. We'll talk more about that later. But let's go ahead and take a look at some examples. Here's question number 1. It says, write a proportion that could solve for x, then solve for x. So you can start with any number up there. I'm going to choose the 12. And so I can set up the proportion 12 over, and then I can choose, there's a couple different things I could choose. I could choose the thing that's on the same side, so 12 over x. Or I could do 12 over 6 and just go across the triangle. Both of those would be good ways to start. I'll do 12 over x. Now, since that's all on one side, I did the top part over the bottom part. I go to the other side and do top part over bottom part. So 12 over x equals 6 over 7. And that's a good proportion. And we'll cross multiply and solve that. But I also want to give you another example. What if instead of starting off and doing 12 over x, what if I did 12 over 6? Went from the left side to the right side. Well, then if I do the same thing down below, left side over right side, I would get x over 7. That's also a good proportion. So no matter which way you set it up, you're going to cross multiply. And you're going to get 6x equals 84. Do a quick division. You get x equals 14. Question number 2. Same deal. Those sides are split up proportionally. So we can start anywhere that we want to. I'm going to choose to start with the 20. And I can set it up as 20 over, let's go with 16. Okay, those two are along the same line. That's a good way to start. And then I'm going to do the same thing to the other side of the triangle. So if I started with 20 over 16, then the other fraction would be 38 over x. Or yet another way to set it up, if I start with 20 and instead of staying on the same line, what if I take that 20 and go across? So 20 over 38 equals 16 over x. Both good proportions. So cross multiply, you get 20x equals 608, and divide by 20, and you get 30.4. Number 2. This is the triangle angle bisector theorem we were talking about. So basically, if I have an angle bisector, this side that the angle bisector goes to gets split up proportionally. So what I can do with that, I can set this up, and I'll start with 8. And I can set it up 8 over this thing that's on the same side as the 8. So 8 over x. And if I started with 8, I need to start with 12 on the second fraction. So 8 over x equals 12 over x plus 2. Or another way I could have set it up, I could start with the 8 and do 8 over 12. So left side over right side, and then x over x plus 2. Both proportions are good. Both proportions will cross multiply. And so I've got to do 8 times x plus 2 equals 12x. And when I do the 8 times x plus 2, I have to distribute. So 8x plus 16 equals 12x. Subtract the 8x from both sides. Then divide by 4. And we get x equals 4. Question number 4. This one's a little bit different, so I need you to pay attention on this one. The 5 and the 8 look normal like the other problems. But then over here on this side, I've got the x. That looks normal. But that 39 is taking up the entire side. So since that's where things are funny, that's where I'm going to start. So I'm going to pick to start with the x. And then the next number I'm going to pick is the 39. So notice what I'm doing there. It's the one piece over the entire side. So when I do the same thing to the other side, I'm going to start with 8. But then I have to do the entire side. So not 5, but 8 and 5 together. And so 8 and 5 together is going to make 13. So that's what I'm going to put in my proportion. I'm going to put x over 39, the piece over the whole thing, equals, did I say 8? X over 39 equals 8 over 13. Okay? Cross multiply and divide by 13. I get x equals 24. That one was a little tricky. Question number 5. This is that triangle angle bisector problem. So I'm going to choose to start with the 10. And I can set it up as 10 over x plus 2 equals 14 over 2x plus 1. Or alternatively, I can start with the 10, and instead of staying on the same side, I can go to the opposite side and go 10 over 14 equals x plus 2 over 2x plus 1. Cross multiply. I have to distribute twice here. So 10 times 2x, 10 times 1, 14 times x, 14 times 2. Let's get all those x's together. Let's subtract by 14x on both sides. Subtract the 10 and divide by 6. Question number 6. Okay, so this is the thing that the triangle doesn't come down and meet and make a triangle, but it looks like if you extended the diagram, it would. It's still going to work the same way. We're still going to set up a proportion. I'm going to start with 2, and so I can do 2 over 7. And then over on the other side, x over 9. And it almost looks like the proportion sets itself up. Okay, these problems are very intuitive. Or instead of doing 2 over 7, I could do 2 over x and slide across the top. And then my second fraction, I'll slide across the bottom, so 7 over 9. Both are good proportions. Cross multiply, and I get an ugly answer. I get x equals 18 over 7, which is going to be like 2.6 something. I don't know. I'm fine if you leave it as 18 over 7. Last example. Okay, this one's a little bit tricky. Okay, there's no x in the problem. I just have a bunch of numbers, but it tells me to find ln. So ln is that length right there, which covers 2 segments put together. So that ln, I'm going to go ahead and call that x. And then I'm going to do x over the 2.6, so still along the same line. Now, if I do the same thing to the top line, I'm going to have to do the same distance. So this covers 2 lengths. So on top, I'm going to need to cover 2 lengths. So the 1.4 and the 2.2 together. So when I add those up, I get 3.6. So if I did x over 2.6, then I will do 3.6 over 2.4. Or alternatively, I could do x over 3.6 equals 2.6 over 2.4. Okay? Hopefully, the more you do these proportions, the easier they get. All right? So I can look at these and I can set up very quickly. And the more practice you get, you'll be able to set them up quickly too. Cross multiply here and let's finish this up. 2.4x equals 9.36. Divide by 2.4 and I get x equals 39. Well, I hope that made sense to you. Hopefully by this point you're good at setting up proportions, and this is just an extension of that. Hopefully this is a very easy lesson for you. If not, shoot me an email, and I hope you guys do well. Have a good one.